we're on page 77, looking at number 17, and the question is a physics application here, and the more force that you apply to like a spring, the longer the spring stretches, right? That's the idea behind here. Hooke's law states that the force required to compress or stretch a string within its elastic limits is proportional to the distance that the spring is compressed or stretched from its original length. That F equals K times D, where K is the measure of the stiffness of the spring, and it's called the spring constant. The table shows the elongation D in centimeters of a spring when a force of F kilograms is applied. Okay, so we changed the weights that we put on the spring, and you see how long the spring is stretched, right? Does everybody see that? Okay, we're going to, it says sketch a scatter plot. What we're going to do is, okay, I want to clear everything here. Okay, I got everything clear. All right. So, what we're going to do is, I want to show you how to put the data in a scatter. You can put a scatter plot in your calculator. Resetting everything. So here's how you would do that. You see this stat button? Hit that, and I'm going to write down for the scatter plot. And this is first. We hit the stat button. Okay? And then you're in the edit column. The first thing you really want to do is just hit edit. Okay, so I'm going to go stat to edit. Hit enter, and it looks like you've got some tables that you can put data in. All right, is everybody seeing that? You have things in there already. Anybody have stuff in there already? You got, it's not empty, your columns aren't empty? Okay, if you want to empty a column, just go up to the column heading, L1, hit clear and enter, and it'll clear the column out for you. We're going to put stuff in L1 and L2. Okay? So the F column there is 20, 40, 60, 80, 100. Hit 20, enter, 40, enter, 60, enter, okay, and so on. We've got numbers in that column. Then the corresponding D column is, the D column, I've got 1.4, 2.5, 4.0, 5.3, and 6.6. Now, I'm going to stop there for a second. Has everybody got the data entered into those two columns? Okay. Anybody need more time? All right. Now, we're going to use this data in a scatter plot. So the next thing we do is hit second, and then where the y equals button is, the second function of it is stat plot. So second stat plot. Oops, second stat plot. Everybody see that? Yeah. Yeah, sorry. I did that last period. Okay. Repeating those mistakes. So I hit second, and then I get the stat plot. And I'm going to use plot 1. And I'm going to hit enter. And I'm going to turn plot 1 on. And if you'll look, you've got choices of the type of plots you want to make. And this first one here is the scatter plot. And that's what we're trying to do right now. Got it? So I'm going to leave that highlighted. You have choices on what you use for your X and your Y. I have data in L1 and data in L2. So my X variable, I'm using L1, my Y variable, L2. And so I don't have to change anything, but I could. If I wanted to do L3, for example, I would go second, and if you look above the 3, there's an L3 there too. An L3, and you look, you can change that. Now I don't want that, I want L1. So I'll go second, and then number 1 is L1. Okay? So, the next thing that I would do is really look at your numbers that you're putting in. Because I want to set the window. Oh, and these here, I'm using this for my points to mark the points. You can use these plus signs, or you can use a dot. I'm going to use that. It's up to you. Just hit enter when you get to what you want to use. Now, I'm going to go to window now. This is not, negative 10 to 10. When I look at my X column, I've got 20 to 100. I'm not going to see anything on the graph if I leave it like this. This is the standard graph. So I'm going to change. I'm going to go 0 for my lowest X. I'm going to go a little higher. I'm going to go up to 120. It goes up to 100. I'm going to go a little past that. All right? And then I'm going to scale that. I'm going to scale that by tens. All right? Just the little marks. If I scale it by ones, I'm going to have 120 little marks that you won't see. It just looks like a solid line. So I'm changing the scale, the little tick marks that they put. And then Y, I'm going to go 0 again. 10 goes up to 6.6. How high? 10 may not be too bad. I'm going to go 8. And I'll keep the scale by ones on the y-axis. Is everybody clear on what's happening? Okay. Now I think if we have our stat plot on, we can hit graph, and we'll have a nice, pretty little scatter plot. Okay, so second stat plot and then graph. Does anybody have something that doesn't look a little bit like that? Okay. I just hit graph. You have equations in there.
Oh, maybe I have an equation.
Everybody seeing it? Okay. Now, for the line of best fit. For the line of best fit, I want you to go to Stat. Go over to Calc. Stat, then Calc, and number 4 is len reg ax plus b. Go down to that. Len reg, linear regression is what it is. Ax plus b. Okay. Now, your newer calculators probably give you like some prompts to put in. Am I right? Okay. For your x, put L1. For your y, put L2. What I have to do, I don't get those prompts, and it's the only data I have, so I probably don't have to do this, but I'm going to. I'll hit second L1 and then comma second L2. It doesn't tell me what to put in for x and y. I have to know those parameters. Okay? If you've got an older one like I do, you can do this. Is everybody good there? Okay. Comma is right above the 7. Okay? And then hit enter. And you'll look at this. It says y equals ax plus b, right? It gives us a value for a, 0.066. Gives us a value for b, is 0. So our equation is y equals 0.066x plus 0, ax plus b. You with me there? Everybody there? Well, let's actually just put that thing in then. Y equals 0.066x plus 0. I don't have to put the plus 0, but for dramatic effect, let's do that. All right. Now hit graph. Look at that. Woo! Goes right through those points, huh? Now, it's not perfectly correlated. You see this is a little bit below the line, and this is kind of above the line. It does slice right through those last 3 points, though. So, all right. So that's the line of best fit, and it's figured out by a least squares regression calculation. All right, is everybody there? Okay, Sydney, where am I backing up to here? Okay, do you have the scatter plot? You have the scatter plot for the bit making the line. Okay, let's go to stat. Let's go over to calc. Let's go down to linreg ax plus b. Hit enter. And then hit enter again. Oh, actually, does it ask you for x? Hit L1 for x. That's second and 1. And then does it ask for y? Okay, second and 2. And then I think you may have everything you need. Is there anything else that wants there? Just hit enter then, maybe. So you got it? And then I just plug that in. So now I just plug that into the y equals equation. And it put the line in there with those points. Okay? All right. Now, it says use the model. So the D, the distance of the stretch of the spring, is equal to 0.066. F is the force that's applied, or the weight that's applied to the spring. And it's plus 0. I'm just going to leave it like this because it is plus 0. It says use the model from part C to estimate the elongation of the spring when a force of 55 kilograms is applied. The force is 55 kilograms. Now, I'm going to just take that unit off there. What is 0.066 times 55? Anybody got it? 3.63. And I think I read that that's centimeters. That's how long, much longer it got in centimeters. for that particular spring. Any questions? Yes? Nope? Okay. Then I do want to show you something that you can do. You look at your graph. If you go second calc, the first thing up there is value. Have you ever done this? Where you put a value in? I want to put 55 in. Hit enter. And it shows you that point. You can see y equals 3.63. I don't use that option very often. It's kind of neat that it's there. Okay? Any questions on that process? All right. Then let's have you turn the page to 78. And do number 23.